Today we are writing chemical reaction. Out of four basic types of chemical reaction, combination reaction, decomposition reaction, displacement reaction, and acid-base reaction, I want to start with combination reaction. We are doing these four basic types of chemical reaction. What is combination reaction? The chemical reaction in which two or more than two elements or compounds combine to form single compound, then the reaction is called combination reaction. And before writing this combination reaction, all these are the example of combination reaction. I have taken just left hand side only. Before writing this, you have to be very clear about some of the elements which always takes part in the chemical reaction in diatomic state, just like this state: hydrogen H2, nitrogen N2, oxygen O2, fluorine F2, chlorine Cl2, bromine Br2, and iodine I2. These are the elements, these 7 elements, which when takes part in the chemical reaction, they always appears in diatomic state when they are free. And when they combine with other, then normal rule we are following normal rule. Just for example, this, let's start. Hydrogen is diatomic, that's why we have to write S2. And bromine, it is also diatomic, that's why Br2. When hydrogen combines with bromine, so certainly we have to write their symbol as Br. And we have to exchange the valency because this is a compound, and in compound element combines in such a way that we have to write their molecular formula by exchanging their valency. That's why hydrogen, its valency is 1, bromine 1, equal valency, that's why no exchange. So this is the chemical reaction, but the left hand side and right hand side is not balanced. The number of atoms of the particular element in right hand side should be equal to the number of atoms of the same element in left hand side. Here bromine 1, here it is 2. That's why I want to balance it by taking 2 here, and hydrogen is now 2, hydrogen 2. Now equal, left hand side and right hand side is balanced chemical equation. While balancing chemical equation, we have to take the number in front of the elements or compounds. We cannot write at the bottom because the number which comes at the bottom comes by the exchange of valency or in diatomic atoms. Okay, what is the name of this compound? Hydrogen bromide. Hydrogen, hydrogen bromide, bromide. Now let's talk about ammonia plus water. Ammonia, I told you in previous class also, the name doesn't give us clear idea. We have to remember ammonia is an acid, this is a compound, and water is another compound. Now two compounds are combined to form another compound because this is combination reaction. When ammonia dissolves in water, it forms ammonium hydroxide. Now we have to exchange the valency. Ammonium valency 1, hydroxide valency 1, equal valency, that's why no exchange. And this is the name of this compound is ammonium hydroxide. Look at the name. Now we have to balance this equation. Looking at this, hydrogen, here it is 1, here it is 4 and 5, 4 and 1 5, 2 plus 3 5, oxygen 1, nitrogen 1, nitrogen. It's already balanced, that's why we don't have to take any number before the compound. Okay, let's talk about this third one. Iron, its symbol is Fe. It's not diatomic, only these are diatomic, although we are not writing 2 when we write their symbol. Oxygen, it is diatomic, O2, that's why. Now when iron combines with oxygen, then if it is ferric oxide, then iron combines with oxygen. It's not told iron oxide or ferrous oxide or ferric oxide. Let's say ferric oxide. Ic means maximum valency of iron. Os means minimum valency of iron. But we are taking, if ic, then we are taking 3. If we are taking os, then we are taking 2. we are taking 3. The iron valency 3, oxygen valency 2. Valency of oxygen is given to iron and valency of iron is given to oxygen. This way, this is correct molecular formula of ferric oxide. Now I can write the name of the molecule, name of the compound, ferric oxide. If you want to write just iron oxide can also be written. Iron oxide may be ferric or ferrous. But this reaction is not balanced. Let's balance this equation. Here oxygen 3, here it is 2. Here odd number, this is even number. If odd number and even number comes in two sides, then the odd should be converted to even by taking 2 in front of that molecule. 3 2 is 6. Now here it is 2 only. 3 2 is 6. Oxygen is balanced. Now it's turn of iron. 2 2 is 4. If we take here 4, then iron is also balanced. This is a combination reaction in which two elements are combined. Okay, let's talk about magnesium and nitrogen. Magnesium is symbol is Mg. We are not writing 2 because we are not writing valency. If it is diatomic, then only we are writing 2. These are, we are writing 2. Other are monoatomic. That's why we are not taking any number at all. They are symbol only. Nitrogen, it is diatomic N2. That's why when they combine, then what happens? We have to write symbol only, magnesium, nitrogen, magnesium nitride. But we have to exchange the valency. Magnesium is valency is 2, nitrogen is valency is 3. That's why 3 should be given to magnesium and 2 should be given to nitrogen. And the name of this compound is magnesium nitride. Magnesium Nitride, nitride. Nitrogen is combined, that's why we are writing nitride. If chlorine is combined, then we will write chloride. Now this equation is not balanced. We are going to take it from this side. Nitrogen 2, okay. Magnesium 3, here 1. That's why if we take here 3, here 1. And if we take here 3, then both are balanced, magnesium and nitrogen. Now let's talk about potassium plus chlorine. Potassium, its symbol is K. Why we are not writing 2? It's very simple. We are writing 2 for this one. They are diatomic. Although we are not writing 2. Chlorine, Cl2, it is diatomic. And when they combine, then we'll write potassium K. Chlorine when combines, chloride. Now we'll exchange the valency. Potassium 1, chlorine 1, equal valency, no exchange. That's why this is the correct molecular formula of potassium chloride. But while writing name, potassium when combines with chlorine, potassium CHLORIDE, chloride. Now let's balance the equation. Chlorine 1, chlorine 2. That's why here it is odd number. I made it even. Now potassium 2, if we take here 2, then balanced both the side. Now let's talk about this one. Nitrogen is symbol is N, but it is diatomic, that's why N2. Hydrogen is symbol is H, but it is diatomic, that's why symbol it is written as S2, because molecule we should write. Nitrogen when combines with hydrogen, then we'll write just nitrogen and we'll exchange the valency. Nitrogen valency 3 and hydrogen valency 1. 1 we don't have to transfer. Nitrogen 3 of nitrogen should be transferred to hydrogen. This is correct molecular formula. And the name of this compound is not nitrogen hydrogen. It is called ammonia. AMMONIA, ammonia. Now the balancing is left. Let's balance it. Hydrogen 3, hydrogen 2. This odd number, this even number. That's why let's convert it into even. 3 2 is 6. Now here 2, if we take 3 here, 3 2 is 6. Hydrogen balance. Now it's turn of nitrogen 2, nitrogen 2. It's balanced. This way we are writing a balanced chemical equation. And we started from what? Combination reaction. The chemical reaction in which elements or compounds, 2 or more than 2 elements or compounds combine to form single compound. Look at this, product is single. then the reaction is called combination reaction. And how we are writing this combination reaction, I told you just now. Now another class I'll continue with not combination reaction, decomposition reaction. This much for today. Thank you.